Hi everyone. So last module we talked a little bit about qualitative research, and this module we're going to be moving into quantitative research. So when we talk about quantitative research, we have to start with our hypothesis, and that's what we're going to do in chapter 5 today. So everyone who has a quantitative study will create at least one hypothesis for your research paper. And this is something you need to do with quantitative research. So unlike qualitative research, where we kind of let theory emerge, that we're going to do some looking through literature and upfront and using just kind of the ideas and the theory that emerge. When you go to a quantitative research, you state your theory up front and you state what you expect to happen in your experiment that you're designing. So with that, that explains why every quantitative research has to have at least one hypothesis. So that's what we're going to look at here. And we're going to move into some descriptive statistics, and that's important in quantitative research because we're dealing with numbers. So we have to talk about how we're going to use those numbers, and then we'll start moving into some specific designs and seeing how they can be used in an educational setting. And as we do this, you're going to start seeing those of you who think you have identified a quantitative problem, you're going to start seeing it come together. And you're going to say all this in the design, and that's what you're going to need for your study. So have some faith that it will happen. So let's look at some examples of a hypothesis. The hypothesis, or some hypotheses, the plural of this, so boys in high school achieve at a higher level in single-sex classes than in mixed classes. So that would be one example of a hypothesis. So you're just stating what you think you're going to see. Another example are students who complete a unit on problem-solving strategies will score higher on a standardized mathematics task than those who have completed a control unit. So there's a second example. Third example would be middle school students who have previously taken music lessons will have a higher math aptitude score. So we'll talk about these examples here in a second. So there's another example is middle school students who have siblings will be more popular among their peers than students who do not have siblings. Students who do warm-up exercises before an examination will score higher on that examination than those who do not. And the last example is elementary school children who do not get adequate sleep will perform at a lower level academically than will their peers who have had adequate sleep. So these are some examples of hypotheses, and what we've done is we've identified our variables, as you'll see, and we have to explain the relationship between those variables. So that's what we're going to test. For example, the first one, the one with the boys in high school achieve at a higher level in a single sex class and a mixed class. So our variables are single sex classes, mixed sex classes, and however we've defined achieve at a higher level. So we've got to think about how we're going to define that term, achieve at a higher level. It'll probably be something like report card grades, or maybe test scores. So those are our variables. Our independent variables are the two classes, and our dependent variable is academic achievement. So moving down to get to the students who do warm-up exercises before an examination will score higher on that examination than those who do not. Our variables here are 12 students to you, or who do exercise, the students who do not get warm-up exercises, and then the score on the examination. So our independent variables are the two groups of students, the one who do exercises and the one who do not. And the dependent variable, it's dependent on that, is the score on the examination. So we'll explain all this a little bit further. So you can see why these are good examples of what a hypothesis is. So moving on to the purpose of the hypothesis. So there are several purposes for hypothesis. The first thing is that we simply bring together information so that we can make a tentative statement about how the variables are related. It's a little bit of the type of, there in the middle, I know at the end of the quantitative you may think it's to say that a word out loud. So the main part of the development of a hypothesis is that we want to give the tentative idea of how two or more variables are related. Presumably what we're asking is something that hasn't been done, for it's a unique twist on something that has been done. So a second purpose is to accumulate new knowledge. So in other words, we're putting these variables together because we don't know how their interactions are going to happen just by guessing. So we're going to put them together and we're going to test our assumption. So we're going to create hopefully new knowledge and say, yeah, this is pretty much what happens. And we'll look at that when we get to the statistical part. Quantitative research, the statistical analysis, is going to tell us how strong of a guess we have. It's not really we pass a threshold. It becomes yes, there are parts of yes and how strong these are. So we'll talk about that later on. The next purpose of a hypothesis is then to provide this relational statement that is testable. And remember, we said that theories have to be testable in order to be a theory. And we brought up the specific cases of string theory because it's untestable at this moment. And so therefore it is really a theory. So the way this works is when you begin with the question. Do teachers' written comments on students' papers result in an improvement on the performance? And then you turn that question into a hypothesis. So we're going to start with the question. The question is, do the comments result in improvement in performance? The performance scores on students who have had written comments on previous papers will exceed those of students who have not had written teacher comments on their papers. So you can see how we have that. We took the words of the first statement or the question and we turned it into a hypothesis by identifying our variables, the two groups of students who received comments, those who did and those who did not, and then our dependent variable, the performance scores. So that's how that works, pretty straightforward and simple. The hypothesis provides duration during the research. It helps restrict the scope of the study. That is our fourth purpose of creating a hypothesis. So it's nice when we're asked to consider something here, but we're going to get into this when we talk about where an ex post facto. So that is, we'll just skip that for now. And then finally, the fifth purpose here is it provides a framework for reporting the findings and conclusions of the study. It's really going to drive our study. In other words, deriving the hypothesis. How do we get added research to arrive at the hypothesis from inductive reasoning? Is it from observed behavior or from deductive reasoning? So in other words, inductive is building from the ground up, so that would mean that what we see happening, and deductive is going the opposite. We're going to start in the clouds with theory that says this is the way something should be, and then we're going to work down from that to explain why kids are doing what they're doing. So this slide tells us a little bit about that, how they arrive at hypotheses from inductive reasoning or deductive reasoning. So here are some examples of hypotheses that are derived by inductive reasoning. That again is from the ground up. So the teachers see something going on and they build from there to develop a hypothesis. So a few of these are students learning of computer programming in the middle school grades increases their development of logical thinking. Students trained to write summaries, this is the third one, of a lecture will perform better on an immediate post-test on lecture comprehension than will students who simply take notes. The last one, you can see after-school tutoring programs increase the achievement of at-risk students. So there are several on there. So you can see that through all these examples, they're basically teachers examining things in his or her classroom. They come up with an idea of why things are working, and these would be examples of inductive. Now let's go ahead and look at deriving hypotheses deductively. So to develop a hypothesis that will test the theory in their particular setting, that's how these things are derived. So for examples are theory, achievement, motivation. People have a tendency to strive for success and to choose goal-oriented success. That's a theory called achievement motivation theory. So a hypothesis then would say that there's a positive relationship between achievement motivation for success in school. So when we would be able to go and describe how we're going to measure achievement motivation and success in school, we see if that's going to have a positive relationship. Attribution theory, in that people attempt to maintain a positive self-image, and they explain their success or failure in a way that preserves that self-image. So a hypothesis using attribution theory would be that if students are given a task and told that they failed or succeeded, even though they actually succeeded, those who told they failed say it's due to bad luck. Those who are told they are successful will attribute it to their skill and their intelligence. So you can see here that we began our hypothesis with a theory, and then based on that theory, we're able to deductively hypothesize. So a few more examples of deductive deriving hypothesis deductively would be the famous Gardner multiple intelligences theory. Basically what he's saying there are that people have a number of different separate intelligences that may vary in strength. So our hypothesis then would say teaching science concepts using a variety of approaches will result in greater achievement than when using only linguistic and mathematical approaches. So those of you who say you'd like to do a student-centered classroom, and you see how this difference differentiates then from traditional lecture style, well, here's your theory. That explains what's happening, and it's not just something that we come up with and say, hey, I think this is going to work for me. Actually, there are theories that can support that, specifically in this case the theory of multiple intelligence from Gardner. And that says if you can tap into the different intelligence that your students have, they'll be more motivated to learn and they'll become more engaged. So there's your theory for those of you that say I need to have a student-centered classroom. And that's not necessarily the only theory to use for that, but it's just one that's really important. There's also the theory of cognitive dissonance, which is Fessinger, and that just says people experience discomfort when a new behavior clashes with a long-held belief or with their self-image. To resolve the discomfort, they may change their belief or their behavior. So based on that theory, we could create a hypothesis that says requiring middle school students who smoke to write an essay on why young people should not smoke will change their attitudes about smoking. So when we ask them to write that essay, they know that they should not be smoking. So hopefully that would change their behavior. So one more we see is Vygotsky's theory of cognitive development. And that states that cognitive development is strongly linked to input from other people. So that's a social theory. So the hypothesis would be that tutoring by more able peers will have a positive effect on the learning of at-risk students. So the last theory here we're going to look at is Maslow's human needs theory, and often we hear this called Maslow's hierarchy of needs. And basically, people must satisfy their lower level needs, which are hunger and safety, before they're motivated to satisfy higher level of needs. So a hypothesis that we can derive from that would be children from economically disadvantaged homes who are given breakfast at school will show higher achievement than similar students not given breakfast. So this, we're looking at the theory, and we see that their lower level needs must be met first, which is where we get the breakfast, so we satisfy the hunger, and that will lead to a motivation to achieve higher. Then there is the behaviorism theory from Skinner, and that's the behavior that's positively reinforced will increase in strength. So our hypothesis may be on-task behavior will increase when teacher positively reinforces it. So you can see in that hypothesis that we're taking directly from the behaviorism. When we see a behavior that we like, we will positively reinforce it, and hopefully that behavior will continue. So when trying to develop our hypothesis, it's difficult to say whether it's a good or bad hypothesis just on the surface of looking at it. But there are some things that you can use as general rules, and we can apply these to help us evaluate whether or not they're going to be good or bad hypothesis. So number one is that we have to see an expected relationship between the variables. So earlier on, I was talking about the variables that were in a relationship. That has to be there. Secondly, the hypothesis must be testable. So for example, my car does not start. The hypothesis then is the corresponding to the start. So we look at this first hypothesis, or this first statement, my car does not start. So that's our problem. A hypothesis that we could state was that the car's failure to start is punishment for my sins. However, we are unable to test that, so that would not be a good hypothesis. Another hypothesis that we could make about my car not starting would be the car will not start because of a failure in the wiring system. We are able to test the wiring system, so that could be a good hypothesis for this problem. Again, you have to be able to operationally define all variables for a hypothesis to be testable. Variables such as creativity cannot be defined. So you have to be able to define operationally all variables within the hypothesis. So there are situations where you might use things such as creativity if you are able to find a scale that measures creativity. Other things might be intelligence, but now we have the intelligence quotient, so we can define that. If you think about empathy, there are empathy scales that can be defined. So if you are able to operationally define the variable, then you can use it, but you have to be able to find a scale that would measure that. So, for example, you couldn't say creativity will increase within 5 minutes of medication at the beginning of class. We can measure the 5 minutes, but we can't measure the increase in creativity. So that's an untestable theory. Also, value adding needs to be avoided in your hypothesis. So for example, an after-school program is desirable by a majority of teachers and students. How does one operationalize desirable? Now you might show through surveys that a majority of teachers and students haven't enjoyed the after-school program, so you might be able to do something like that, but you need to make sure that you are able to operationalize desirable or whatever variable you're going to be using. So a third characteristic of a hypothesis, it should be consistent with existing body of knowledge. And that's part of the reason why you're currently working on your literature review. It's just to see what is out there on your topic. So a bad thesis would be, my car will not start because the fluid in the battery has changed to gold. Basically, there is nothing out there that's stating currently that fluid in the battery is changing to gold. So that just doesn't make sense with what we already know. So a good one would be my car will not start because the fluid in the battery has evaporated to a low level. There is information out there that tells us that fluid does evaporate, and that if fluid goes below a certain level, that it can have a negative impact on battery. So it basically has to comply with knowledge that is already out there, and that's again why we are currently working on that literature review. So lastly, characteristic would be that the hypothesis should be stated as simply and concisely as possible. So what we've been talking about so far is called the research hypothesis, and it basically just states that there's a relationship that one would expect to find as a result of the research. It may be directional, positive or negative. I stay away from saying both or asking the question, is there a positive or a negative relationship? When you're with your hypothesis, you need to state whether you think it's going to be a positive relationship or a negative relationship. So actually what we will be testing with our research is called the null hypothesis. And this is written along with the research hypothesis. It allows a researcher to be able to reject the null hypothesis and claim the relationship is not by chance. So you're saying that the relationship is because one variable is reacting to another variable or not. So a good way to think about this is our American legal system, and where we say that we are innocent until proven guilty. So the prosecution has to present enough evidence to convince a jury to reject the notion of our guilt. So the null hypothesis is assumed to be true until enough evidence is presented to show that it is not true. So we'll talk more about this, and if you don't get this right at the beginning, it's okay. It's kind of a confusing concept, but it is very important that we look at the null hypothesis, because that is actually what we will be testing. So the different types of hypotheses. First one we're going to look at, we call that H1, and that's just our hypothesis. So let's look at this one. It says students taught through individual instruction will exhibit greater mastery of mathematical concepts than students taught through group instruction. So you see we have two variables. We have students receiving instruction individually, and we have students probably in another classroom, in a control classroom, where they are being taught through group instruction. We're going to look at somehow measuring the mastery of math concepts. So whatever we decide that the method that we are going to use to measure the math concepts on that could be state tests, could be grades. So we're saying in our hypothesis that the students who are taught individually will do better to master math concepts than students who are taught in a group. So what's our null hypothesis? And you see this is denoted as the H with the little sub-zero, H naught. And that is the mean mastery scores of population of the variable, first variable, of all students taught by individual instruction will equal the mean mastery scores of the second variable, which is in the group instruction, of all those taught by a group instruction. So you can see that can be denoted as H naught is the two mean scores are going to be equal to each other. So the symbols you see used in that, those are Greek letters, and they're used for population, and they look like U's with a long line to the left. And then the different variables are denoted by the sub numbers, the 1 and the 2. So in the hypothesis, we're stating that there is going to be a relationship of positive, that the first group is going to do better with the mastery of mathematical concepts. You see in the null, that's stating that we're not going to find any difference. So if we collect our data and do inferential statistics and we find that there is a difference, the mean mastery scores are not equal, we are able to reject the null hypothesis. That could possibly mean that there is a greater mastery of mathematical concepts as we stated in our hypothesis, and in that case we would reject the null and we'd be able to accept our hypothesis. However, after we do our inferential statistics, and what would happen if we found that actually they had less mastery of mathematical concepts? That's when we would be able to, we would look at the alternative hypothesis. So if you reject the null hypothesis, but find that students taught through individual instruction actually exhibit less mastery through inferential statistics, you will then form an alternative hypothesis to state this. So basically you're able to reject the null, but you're not able to accept your hypothesis because the relationship is different than what you had hypothesized. Then there is an alternative hypothesis. So when we create and test the null hypothesis, we are actually hoping to reject it. So there are specific steps that we would take when we are going to be testing the null hypothesis. First, you need to state in operational terms the relationships that should be observed if the research hypothesis is true. Then we're going to state the null hypothesis. We'll select a research method that will enable the hypothesized relationship to be observed if it is there. So those are going to be our next steps. We're going to gather empirical data and carry out the descriptive statistics. We will then analyze and calculate the inferential statistics to determine the probability that your obtained results could have occurred by chance when the null hypothesis is true. And we will talk about this all in a little later. So if the probability of the observed findings being due to chance is very small, then one would have sufficient evidence at that point to reject the null hypothesis. So we will be going through those types of steps a little later on. So you will see here that it says 1 in 100 chances. Oftentimes our threshold for finding significance is a 5 in 100, so it's 0.05 is what you'll see when we look at the significance, and that just tells us whether or not we have sufficient evidence to reject the null hypothesis if these things happen by low enough chance. Okay, so from here, this is the research plan, and this is if you're going to be doing a quantitative study. So first of all, you state the problem. It needs to be a clear problem, specifying the relationship expected to be found, include the rationale for the study, and a brief background of the problem in theory or related research. You'll see this as part of your literature review. Hypothesis, you will state your hypothesis, and we talked about using operational definitions of the variables to make sure that you are able to define and measure each of the variables. And from there, don't forget to state your null hypothesis. Then you will develop a methodology. You're going to explain how you're going to conduct the study. You're going to include proposed design, the population that you'll be considering, sampling procedures, the measuring instrument, and then any other relevant information that you would need to conduct the study. Once you are able to collect the data through the methodology, you're going to look at how you're going to analyze the data. So we'll talk more about this a little later, and it may be a little difficult to make the determination until you become more familiar with the statistical methods. So you may not know how to analyze the data yet, but we're going to talk about statistical methods, and hopefully you will see how using one of those would allow you to analyze the data. And then you would conduct a pilot study. So we're going to talk about some basic statistical measures, and if you have any questions, please feel free to contact me, and I will try to help you out as much as possible.